Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ. More specifically, if I say it's a multi-step reaction. So what is the product? I request everyone, student, please pause the video. Try by yourself. Whatever answer you get, please write in the comment box along with few words as explanation. Don't worry, after some time you'll have the right answer with explanation. I believe you have tried, so let's start. So what is the major product in these reactions? So this is actually C3H7I reaction with alcoholic KOH, heat, then NBS. What is the product? Now first let's look at the substance C3H8I. So your question will be, sir, two options possible. One, this is N-propyl iodide, or two, isopropyl iodide. How can I understand whatever you are asking for? See, I agree you have a problem. By the way, you may think, sir, C3H7I what? So whenever you get any formula, if you look at C3H7I matches to the formula CnH2n plus 1I. So it is alkyl halide, actually alkyl iodide, and technically if I say it is saturated, because CnH2n plus 2 is the saturated hydrocarbons common formula, so it is saturated. So in both cases, if you treat them with alcoholic KOH, it undergo elimination. Actually I would say beta hydrogen elimination, so HI elimination overall, and both case it will produce this propyl, both case. So it doesn't matter whatever or why I haven't mentioned. So it's, and remember, whenever you are talking alcoholic KOH, so it results elimination, and in presence of higher temperature, I mean heat, prefers or favors the elimination, so it will be alkyl. Now next step, NBS and heat. What is this? If you look at this reagent, this is NBS or N-bromo succinimide, imide. Now what happened if you give heat? So what will be? By nature, if you look at NBS, this bromine is delta positive, or you can say electrophilic. But whenever you give heat, these undergo breakage. So it's a homolytic cleavage, and it produces this nitrogen radical along with this bromine radical. Okay, now these bromine radical, in the next step, what it can do? It can abstract a proton from these allyl position. Now you may think one question, that, sir, in this case this bromine is delta positive, so it is actually electrophilic in nature. So why don't it undergo electrophilic addition on alkene like bridge bromonium as intermediate? No, student, because this heating condition, this N-Br bond is not that much stable. So under this heating condition, it will break down. Now next step, this Br dot will abstract these hydrogen. Okay, what is the benefit? So in this way, it will result this allyl radical. And remember, these allyl radicals are resonance stabilized. What do I mean? So you may think that these will come, one will go there. So in this way, this is the radical. So this radical is distributed over 3 carbon atoms. By the way, if you look at radical is actually 7 electron species, all these radicals. So that is the reason they are incomplete octets, so they are very much reactive. So okay, this radical is produced, but because of this resonance, that electron deficiency as well as the reactivity is reduced to some extent. Now this is the thing. Now in the next phase, what can happen? Next phase, another bromine can attach with this, and it will result in this one. By the way, some people may say, sir, I don't believe in this mechanism, I believe in a different mechanism, like that. So there is a radical, there is my bromine dot. What do I do? The reaction will happen with these double bond. Okay, ultimately product will be same, doesn't matter. Now you may think, sir, then actually 2 equivalent of NBS needed for reaction. Answer is no. Why? Because the reaction have started, and what is the product here? The product here in the first step you may consider HBr, because this bromine abstracted this hydrogen and resulted HBr. In HBr, actually this bromine is delta negative, hydrogen is delta positive, so it can react with this NBS. So what is the product? This NBS, if you look at this bromine, is actually delta positive. So you can see opposite reactivity. So this bromine, they can combine and it can result in bromine molecule. Okay, so again bromine will be regenerated, and these bromine can again be broken down. So lots of pathway possible. What do I mean? the hydrogen will be ultimately shifted to this nitrogen, and it will produce, because from here also you can understand this hydrogen will be taken by this nitrogen. Here also it can abstract, and ultimately it will produce NH. Even these radical can abstract this proton also, everything possible. So overall it will be succinamide, and the bromine atoms attached here all will be attended to this allylic position. So result allyl halide. Okay, and remember one thing, if you look at the formula, delta H minus T delta S, actually I'm talking delta G, free energy change. So high temperature, at high temperature this delta S term is more dominant to make the delta G more negative. So if you look at this substitution, actually allyl substitution, so in this case entropy change is not at all negative, but for addition reaction entropy change is negative. So entropically addition is unfavorable, so at high temperature this allyl substitution is more preferred. Next point. Now in this way what I got, these allyl bromide, and remember student, allyl bromides are more reactive for both SN1 and SN2. I repeat, allyl halides are reactive for both SN1 and SN2, means nucleophilic substitution. There are few substrates like benzyl halide, aryl halide, mom chloride, etc. are active for both SN1 and SN2. I have made a already dedicated lecture, you may visit for further learning. So here if you look at, this is alcoholic cation. Now you may say what will happen, this cyanide is actually student very good nucleophile. So what it will do, it will attack here. Now some people will say, sir, no, your logic is not right, it will attack here. Yes, that's also the same, ultimate product will be same both cases. Okay, now if both are not symmetrical, that time contradiction comes, but in this case both will be same, and ultimately it will produce this allyl cyanide. If you look at, it's a carbon 1 2 3 4. So initially I have started with a C3, and last step since KCN added, so I end up with C4, allyl cyanide. Now let's see the answer. So here if you look at alcoholic H, etc. So whenever student you solve, look at one thing, are all options are C4? It is C4, 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 C4. This is. Now from that, because many time I observe that teacher changes this carbon count, and if you are little clever you can get the right answer very easily. Next, so you can understand alcoholic KOH heat, it's a elimination, and you should remember student this part. This is the answer I know, but if you get this question in your exam or less than 30 seconds, how can you solve? For that purpose, more practice needed first. So alcoholic KOH, so whenever you look at the reagent, you need to understand what kind of reaction. So it's an elimination, produce alkene, alkyl halide, dehydrohalogenation, dehydroiodine, HI removal, fine alkene, then NBS heat of, since heat is given, so it's a allyl substitution, so allyl bromide. Now after that KCN, so cyanide, allyl bromide, KCN, cyanide, simple. So this is more probable, but if you look at here, branching, why, how it's possible? No, it is not at all a wrong option. Now bromine is here, I have mentioned nothing, means only one equivalent of NBS given, so one equivalent of bromine. How bromine can exist? Either this one or this one. And if bromine exists, how nucleophilic substitution can take place? I mean, how the cyanide can stay here? So from that point you can see these two options are wrong. So if you understand that basic concept, you can remove these two options called process of elimination. And if you look at here, it's a simple reaction, so how branching could be possible? So this is wrong. What is remaining? B is the right answer. But such kind of guessing is little risky, so please study as much as you can. So this is the overall discussion. I believe this video may be useful. If you really consider the content of my channel is worthy, then please help this channel to grow. And regarding the logo about my channel, please read this part. So thank you. See you in my next video. Bye bye.